So those are reed instruments. So if I write example here, this one we know. What example shall we write here?
Sir, guitar, bass.
Sir, guitar, sitar, violin.
Sir, guitar, bass. Guitar.
Guitar.
Yes, sir.
What about wind?
Yes, sir.
The
Sir,
mouth
wind
organ.
trumpet.
Mouth organ
Vocal.
or flute.
Yes, sir. Flute.
In this one,
Sir, drum. Tabla.
drum or bongo,
Yes, sir. Bong.
and reed, as we said, harmonium.
Harmonium and
Similar to mouth organ. Fine. Okay. So now let's go to the second part of the chapter, that is reflection.
sir.
Let's go to the second part of the chapter.
Ego?
Sorry?
Sir, you mean ego?
Yes, first reflection, then how echo is occurring. So that for that we need to know reflection. Right? Okay. So reflection of sound. Reflection of sound or light?
Sir.
Reflection of sound or light?
Sir, I have a question, sir.
Hello?
Sound,
Yes?
sir.
Sir, does the bagpipe come under wind or reed, sir?
It comes under wind. See, mostly all the instruments which are in wind, it comes under reed. Okay, so tell me about reflection of sound.
Yes, sir.
Sir, it is known as echo.
By the way, what is reflection?
Sir,
Sir,
bouncing
means
back of something.
bouncing of anything, sir.
Yes,
Sir,
bouncing back.
Bouncing back of. Sir, not only bouncing, sir, bouncing back.
So bouncing back of whatever. So let's write, in short, we can write here
Echo for reflection of sound. Out. Bouncing back.
Echo is the type of reflection of sound, not reflection of sound.
now. Let me ask you a question. Does this reflection of sound follows the laws of reflection of light?
Sir, it does, sir, it does.
Yes, sir.
Yes, sir, it will do, sir.
How can it be possible?
Sir, same
Sir,
as
we
Sir,
want
the
the
where is the
mirrors,
rays,
sir.
sir?
Sir,
So
same
where are
as
the
the laws
rays?
of light.
I'm sorry.
Sir, it follows the same laws as light.
I'm sorry. Does it move in same straight path?
No, sir.
No, sir, it
Sir, it
moves
can
in a
move in
wave
all
path, sir.
directions.
But the laws of the reflection are same as light.
So then we can say all incident ray of sound and reflected ray of sound will be equal. Not ray, incident of sound and reflection of sound will be equal. Angle of incident and angle of reflection are equal.
Sir, I think they sound follows, I think, laws of reflection.
Okay.
Sir, I don't think.
Why you don't think?
Sir, sound moves in all directions, no?
Even light moves in all the direction.
Sir,
We
they
can see-
might be similar, but not all the rules, I think. Sir, I don't know, sir. You tell us.
No, it's true only, nothing wrong here. See, when there is a, let me draw this. Okay, wait, let me show you with one photograph, as usual. Of sound. I want photograph. Yes, I got one.
Sir, is it like sonar?
Yeah, sonar, echo, all these things are example of that.
Sir, sonar is the reflection of sound, right, sir?
Yes.
It sends sound waves and receives
Sir,
it back and
sound
tells
does
the
follow
distance.
the.
Sir, how much speed it sends and how much time it receives, it tells on that, sir, how much it is.
Yes.
Yes, sir. Emitter and receptors are there of that sonar.
Yes.
So sender and receiver. There will be one sender, there will be one receiver on the other.
Sir, sonar basically works like LiDAR, sir.
Yeah.
Sir, it's used to
Instead
find.
of sound, the LiDAR sends lasers, sir.
Sir, it is used to find the depth of the ocean.
Yeah. Depth of the
Sir,
ocean
it
or
reflects below the ocean. Yeah.
Depending upon the echo, like how much, like in how many seconds, then how much distance, like
How much time it takes and
It
how
Sir,
much
depends
speed
on
it
the
using
speed
emits the
of
the
sound, sir.
sound
formula
in
of speed
water.
is equal to distance by time.
yes.
Speed of sound in the water, it will take in.
Right. Laws of reflection. Same as laws of light. So angle of reflection is equals to angle of incident.
Incident.
So second, all three, I'm sorry, all three are on the same medium, or we can say
Same plane.
same plane. See this? They all are in same plane. Incident ray, reflected ray, and normal are in
Same.
same plane. Okay. Application number 1. What's the application? Give me one application and with
Sir,
example.
sonar, sir.
Sir,
Yeah,
sonar.
sonar,
Sir, sonar in submarines.
echo, as you already said. Then
Sir, can you hear me?
yeah, I can hear you.
Sir, it is
Sir,
also used in
bats use
EEG,
echolation,
right?
sir. Sir, bats use echolation.
Yes.
Sir, ECG.
See that again?
Sir,
Sir,
ECG
that
is right.
ECG, electrocardiogram.
Yeah. ECG. Yes. Hearing aid. Then stethoscope.
Yes, sir.
Even that works on the same principle.
Sir, like it's a ultrasound and all are used to find the, like whether the child is normally developing in the womb of
Yeah.
Yeah.
And
So sonography.
Sir, megaphone.
loudspeaker. Yeah,
Sir, loudspeaker.
megaphone. Yeah. Okay. Let's discuss each one by one. Let's start with Mr. Echo. Now, what is echo?
Sir, also dolphins and all other sea animals use echoes to communicate.
What is echo?
It is the resound of
Echo
something.
The reflection, the reflected
Resound
sound.
of and
Sir,
vibration.
The resound of the sound which was spoken or taken.
Yes.
Resound of an vibration.
So it's a reflected sound.
It is reflection. So we can say reflection of sound.
Yes, sir. It is a reflection.
From some rigid place, rigid surface, like a cliff
Yes, sir. Cliff, hill or moon.
or even wall.
Or a empty space.
Sir,
sir.
if enough distance,
Yes,
even wall.
sir.
It is echo.
So our minimum distance is 17 meters for.
Yes, there should be minimum distance. Even actually, sometimes this happens with less than 17 meters also.
Sir, it depends on the
Sir,
temperature and
but
other.
for proper echo, we need 70.
Yeah.
Sir,
Now,
also depends on the other
see,
factors. Sir,
If
like
you
the
have observed, like if you're moving into new room, new house, so the
yeah, sir,
house is
everything
not
empty.
unfurnished; it's totally empty. So when
Only
you
walls
speak,
are there,
yeah, that echo
and
will,
we can hear echo, sir.
yeah. So it's not
Sir,
like
if we
100%.
shout in the temple dome, we hear echo.
Sir,
Sir,
sir, the light is reflected, sir, instead of absorbing like the other objects. The
Sir,
wall
when we like go to a new house, we hear echoes because there are no objects to absorb the sound like out.
Yes,
Yes.
sir, absorption.
Exactly. So echo is used where? Who is using echoes? Examples like we. Okay,
Sir,
we know.
Sir, the marine animals use echoes to
Yes.
communicate.
Some animals, with some animals, some
Sir,
bats.
to find their prey
Sir, bats
also.
use the property. Sir, bats use the property of accretion to like find its prey or not bump into objects.
Yeah. Because they are like they don't have eyes. They are like blind creature. So they have very high sensitive ears. With the smallest to the highest they can hear.
Sir, application of echo can be used in sonar.
Yes. Sonar. What is sonar? Abbreviation of sonar?
Sound navigation and ranging.
Yeah. Sound, navigation, and ranging.
Sir, I didn't
Sir, used for
understand
measuring
sonar.
distance.
Sir, can you explain sonar again?
Sir,
Yeah.
like the echoes are also used like whenever a song is played, the echoes are used because it feels good when the song is continued for a bit long.
Now see, sonar, how same way sonar is used for what? Detecting things. Like as he said, for underwater things, underwater object, like especially by submarine. Like what is going inside. Outside we can see through it, okay, but in water it's difficult. So they use this technique, that is sonar technique.
Sir, echo diagram also. Like it's used for hearts.
Sorry?
Yes, sir. Electrocardiogram.
Yeah.
Yes, sir.
Okay. But how does it work? What it do?
Sir, it sends sound waves inside the
Yes, sir.
water and sees when they are reflected, and according to the speed of sound in water, the distance is calculated.
Yeah, exactly. So if I draw it here,
Sir, it's echocardiogram, like it sends the sound waves to our heart and like bounces back. It gets,
Yes, sir. Same in sonography.
yes, sir, same as sonar.
It sends signals and receive it back. It receive it back. So this distance where it is striking and returning back, it is calculated by the device. There is an object here. It will strike the object and it will return back. So by this distance, you can identify, okay, there is some big object, small object, what is the size of the object. Understood what is sonar?
Yes, sir.
Yes, sir.
Okay. Now, so let's see conditions.
Sir,
Conditions for, yes,
sir, sir, does radiation, not sir,
radar.
radar, sir, radar.
Yeah. Radar
Sir,
what?
does it use this echo?
Yes, similar to
Radar.
that. We'll see that
It
also.
sends electromagnetic wave.
Yeah, we'll see that also.
Yes.
Okay, what are conditions for forming echo? Minimum distance, as you said,
17 meters.
17.2 meters.
17.2 meters.
Next, wavelength,
Maximum.
minimum, maximum can be any.
Okay,
Any-
sir.
Sir, but it should reach,
Yeah,
depends on how loud it is. And the intensity.
depends, yeah. So wavelength of sound should be less than height of reflecting body. Right? You cannot say that even that stone, we are taking stone and we cannot say why it is not echoing. Stone is also a small, like we can say stone is also a miniature of mountain.
Yes, sir.
Sir, if the lambda is the height of the, I mean, amplitude is the height of that, then we,
Lambda is wavelength.
not lambda, sir, amplitude.
Okay.
Sir, amplitude means loudness.
Yes. So wavelength of sound should be less than height of reflecting body. So we need at least bigger object. Next, third point we can write as you said just now, like it should be, intensity should be that much, it should be like reaching somewhere. Yeah, somebody said that one.
Loudness.
Intensity, yeah.
Intensity is needed.
Yeah, that intensity should be sufficient.
Sufficient enough to reach the
Sufficient so that it can be heard. Knowing that, we have some types of echo. We'll see small things about that and we'll move to next. Types of echo. It is instantaneous. What does this name suggest? What do you mean by
Sir, means
instantaneous?
within
Short
Sir,
period.
immediately.
Immediately for very short time or short duration. Example, we
Very
can
short
say
seconds.
claps.
Sir, it is heard for very short.
Explosion of
period.
fireworks.
Okay, somebody said something, but it was like not audible. Like,
The explosion of fireworks.
yeah,
They said explosion of a fire.
explosion. Okay, yeah. Second one, we can say syllabic echo. What is syllabic? Means syllable. What a syllable? Some words.
the same sounding type word.
Yeah. So some words, spoken words. That is syllable. So from the name we can say, what we can make it, like some words, speaking words or spoken words is called syllable echo.
Like the words which are spoken, which are
Yeah.
reflected back. Like a,
But they should be clear, which can be
which
properly
can be
audible.
understood.
Yeah, understandable. Even that is also very short duration. So we can write here words.
Sir, can you explain instantaneous echo again?
Instantaneous echo means for a very short
Immediately,
duration,
very. It is heard for very short period.
like gunshot, claps.
Okay, sir.
And especially you have heard this type of echo that is successive.
Sir, again and again we get reflections.
Yeah, like in mountain or
Sir,
cliff.
it's also called reverberations.
Yes. Successive echo.
Sir, if loud enough, it might echo for 5-6
Yeah, even
as intensity and all the factors.
we can hear this echo when there is a tall building.
Sir, when we are in a big shopping mall, we hear like 3-4 echoes.
Yeah, provided there should be not much people inside.
Yes.
So we can say successive echo can be here in hill or open area, or we can say vast open area, big open area, large. Okay. So let's go for next thing. That is what thing shall we go? Megaphone. Echo was number 1. Let's go for number 2. That is megaphone or loudspeaker. What's megaphone?
Sir, it is a device which has a mic and which will like amplify your sound.
Sir, it will amplify the
Make it
sound.
loud.
It will be louder.
It will amplify and to hear, like it will amplify and make it loud.
Okay. So what happens when, like, how it amplifies the sound? You know shape of megaphone, right?
Sorry, sir, reflection of sound, sir.
Sir, it's like triangular kind of.
Megaphone. Let me just show you a picture. Yes.
Sir, is it like the sound rotates inside or something?
Okay, why? Let me just show you first, then I'll ask you a question. Oh, it became so big. Okay. Why the shape of this megaphone is such?
Sir, does it work like a funnel?
Yes, it works as a funnel.
So like a vibrating, I think, air column.
Main thing, when we speak, this person who is speaking, it will go every direction. But I don't want that to be disturbed. I want all energy to be concentrated on particular direction. That is this way. That's why the shape of this megaphone
Sir,
is
it
such.
basically works like a music instrument and
Yeah.
Or even if we keep, if we make an oval shape like around our mouth, then when we speak anything, it goes
Sir,
in
we
a
speak
straight
something,
manner.
it
If you take a
constantly
cone from a
reflects
paper,
and sends,
still it
sir.
will work.
Yeah.
Sir, it will exponentially
Like,
grow that, sir.
amplifies the
Yes.
sound, sir.
So this is what a horn shape. We can say horn shape. So what will happen? It will prevent from spreading
Yes, sir.
of sound energy.
Sir, nowadays megaphones are like electric, right, sir?
Yeah.
Yes, sir.
Instead of acoustic, they're electric.
Yes. So there we have to use less energy. So there will be a mic here. We don't have to shout. There will be a mic here. And it will be
Sir, if we shout, it will be.
Or it will amplify the sound.
exactly.
Sir, it works like an echo button much louder, and it will exponentially grow that.
Okay. It works as a
Sir, when you touch a megaphone, it vibrates very bad.
okay. So this circular rim, it is a, we can say it's a dome, or some, its name as whispering gallery. If we say something here, it's get reflected. Okay.
So what's
Sir,
that
does it work like a
cylindrical
solar
kind of
cooker?
thing inside the funnel?
I'm sorry.
Sir, does it work like a cooker, like solar cooker, sir?
Solar cooker.
Like
Does
it
it-
reflects off
Sir,
and no.
Can you
Sir.
compare
sir,
this
solar cooker
megaphone
has
with this?
a mirror inside to reflect the rays.
Oh, okay. Light rays. It will reflect light rays
Yes, sir.
towards the. It focus on towards the center. It wants that light rays to the center. To a
Sir, I
point.
was asking, what is that cylindrical thing in the between of that funnel?
This one.
Yes.
See, this might be something.
Is it the like? Is it
Like-
what releases the sound?
Yeah, this is from here. Sound comes together. Like not good. From here, it's there will be hole. If I show you inside part, I don't know if it's there or not, but there is a hole from here, inside side, inner side. There will be hole from here, and it will be reflecting. But what is it? What is the name of this one that I don't know? Let me check. The name I don't know.
Sir, what, sir?
This name I don't know. What is it called? That cylinder part.
Here they amplify and then.
Maybe funnel. They will call as funnel.
And like
Wait, I can't find any things like that name. Okay, whatever it is, I don't know that name. Let's go for next then. Just this work is for amplifying. There will be a chamber inside. Okay, which will like amplify that sound. It will work as a echoing place. Inside there's a chamber, small chambers. Okay, so megaphone is for the shape of the megaphone is such that so it will prevent from spreading. So hearing aid. What is hearing aid?
Instrument used
Yeah,
make the deaf people hear the sound.
exactly.
Like,
It's a device for
sir, it's a device for people to amplify the sound and can
or we can say
Be
who
depending on what's the issue with the patient's ear.
exactly. So hearing aid is the device which is used for the person who is hard for hearing. We cannot say they are deaf. We can say hard of hearing.
Sir, maybe that he hears just loud sounds. He's unable to.
Yeah. Hard of hearing. We should not say they are deaf for something. We should say hard of hearing. The person who are hard of hearing. They hear louder noise or louder volume, it should be. So you know the shape, right? It will be like this way. There will be one ear plug inside. It will be fixing in their ear
Got it.
inside. Yeah, but nowadays there are some instrument which is coming like this. It will just fix inside your ear canal. Where is our ear? We have ear here, right? It will fix here. Very small. Not just here, sorry, here. In between here, small, very, very small it will be. Now fourth one, there is stethoscope. What is stethoscope?
Sir, it is the
It is
instrument
used by the
used to
doctor.
like hear the heartbeat of the
Yes, heartbeats of
patient.
used by doctor.
Yes, sir.
Sir, it's
Right.
like based on echo.
Doctor. This is especially for lungs. How much fast it's moving, like inside our blood circulation and all heartbeats. How much fast it's moving?
Like they can hear through the echoes produced by the
Hearts and lungs. So what does stethoscope have? Like why we are able to hear that something from that stethoscope?
Sir, it has a membrane-like thing on that circular
Yes.
ending.
There is a diaphragm.
so that
Yes, sir.
And there is a headphone-like structure that is earpiece.
Yes, sir.
sir, it's because of the echoes that we are able
Yeah,
to hear.
for the same reason.
Sir, earlier
Sir, I
doctors
think
used
it
to
has
keep
something
their
inside which
ear
makes a
on
sound.
the.
Sir, is there a bell inside that?
Yeah, bell inside. Let me show you a picture then. Mr. Stethoscope, where are you? Stethoscope. Okay. Let me ask parts.
Sir, it has a sort of mini microphone. Sir. So the sound will transmit through the wire to the headset to the ears.
Yes. Stethoscope. And it is. Yeah. It's a bell-like structure and diaphragm you can see.
Yes, sir.
And this is earpiece.
Well-
So from here,
Yes, sir.
sound will travel to our ear. So then doctor will understand, okay, this heartbeats, so it's low or high or whatever it is. They know better.
Yes, sir.
Yes, sir.
Sir, like there's a beat of rhythm.
Sir, they like tell like
They'll listen to the
depending
rhythm
upon
and
the
they'll tell.
frequency. Sir, like
Yes,
depending
sir.
upon the frequency of heartbeat, they tell if it's low or high.
Sir, if it is irregular, it's palpitating.
Yeah. I don't know that thing. No? I'm very bad in bio things. Okay. So speed of this echo, like speed we know, distance by time. But speed of echo we can say by going and coming back. So that is the distance we need to count. That is 2D. Of suppose there is a wall here. So it will go there that at distance D and returns back at distance D. We are standing here. Sorry?
Sir, but echo uses the speed of sound, right?
Yeah. So by this one, we can find like what is the distance, what is the time taken by this. If you want to know distance, minimum distance for a second, let's take speed of sound as 340.
Sir, you can give distance and speed. You can use speed and time.
2D. Right? Let's take sound as 0.1 second. Because sensation for our brain is 1/10 second of sound. Our brain reacts with the 1/10 second. That means 0.1 second. So let's find distance 2D. We are taking speed of sound as 340
Sir, is
into.
it 7?
Sir, can we take 344?
Yeah, take 344.
Sir,
D
then
will
it's
be,
17.2.
yeah, 17.2 meters. So we got that minimum distance. It's similar.
Yes,
Yes.
sir.
Yeah. So if I want this in, like in short, minimum hearing distance should be this much.
Yes, sir. Maximum it depends on intensity.
Yeah. Even if I say from some distinct object, like if we can hear echo, our minimum value is also 1 meters. We can hear from 1 meter source also this way, but it will be minute.
Sir, the echo will be inaudible.
Yeah, it might not be echo for us. It might not be. So let's take a numerical with that. Then we are left with some sonic sounds, ultra, infra, and those things, and reverberation. Question number, I don't know, whatever it is, you choose it. A man stands in between two cliffs, X and Y, such that he is at distance of 66 meters